Alrighty, so it's 9 a.m. and we're gonna go ahead and start talking about Pygame and making a very, very simple game sort of thing. Um, as I've said with you guys, I am not feeling great, so if I kind of skip over things, I'm sorry. So basically what we are going to do is we are going to look at a drop game where things are falling from the ceiling and you're trying to click them before they hit the ground. And this is done in Repl. It's done in Python and Pygame, but Repl is an online IDE, which makes it nice, so you don't have to worry about downloading anything extra. If this will actually do its thing and update like it's supposed to, life will be good. Okay, cool. And I'm finding that that's kind of an issue. You're gonna have to run this a couple times before it actually runs. There we go. So when it hits the bottom, it gets a new screen that says play again, yes or no. If you click yes, they'll start again. And if you click no, it'll just close out of the application. And yeah, the sprites that I use for this are kind of big, so you would probably want to scale them, but again, I'm not feeling 100% great, so I didn't do it. If y'all have something specific that you want me to talk about next week, which again is meant to be a lab week, please let me know, and I will do that for you. So, with that said, this is the code that I've linked to you guys, so it's nice and commented. It explains what I do. You guys also have the written document, which explains even further. But what I'm going to go ahead and do is I'm going to go ahead and just write the code. But again, you guys have this page, which has the PDF as well as the code, the link to the code that's commented. Okay, so let's come back to Repl. Add a new Repl, Pygame, call it whatever you want. I'm gonna call mine Pygame Chicken Demo. Create the Repl. And then, so one of the things that we kind of haven't really touched on is the fact that there are examples, or tend to be examples, if you click here, go away. If you click here, they'll bring up some examples for you so that you can import them. Some of them might be helpful, some of them might not be helpful, but for our case, we can just ignore it. And the very first thing that you generally are going to see or going to want to do is you're going to want to start with your import statements. Of course, we have to import Pygame. That's kind of the number one that we're going to do. But in general, the three that you tend to use the most often are sys, which is system, import Pygame, which of course is Pygame, and then import random, which is our random library for our randomizer. So those are the three that you just kind of do. So it's not the worst thing in the world to have them there, even if you don't use any of them. Well, you will use Pygame, but sys and random you may or may not use depending upon things. So to start any kind of Pygame game, we have to initialize it. So we use pygame.init, which is the initialization function. That says, hey, load Pygame, let me use all the Pygame functions and all the classes and everything that are Pygame specific. And as you can see, it removed the little green squiggly line from under here saying, yeah, it's used now. Cool. Awesome. So basically, everything inside of here, this area that's going to go right underneath here, is going to be your initialization. It's going to be all your loading things if you're thinking back to Lua. And then you're going to eventually have kind of like a drawing area and stuff like that. So to begin with, the first stuff that we kind of want to do, or we think about when we're initializing, is that we need to create kind of our screen size, what our background is going to be. Maybe we want to set a caption in the top because that always looks nice. So the first thing we're going to do is we're going to set all that stuff up. And there's a few different ways to do it. The way I like to do it is to set width and height as separate variables. So width equals 800, height equals 600, because it's a lot easier to call a variable called width than to have to like actually pull out the tuple. And then we say size is equal to width, comma, height. And that's just, thinking later down the line that we're going to want to use width and height. We're going to want to see those variables, or we're going to want to manipulate based off of those variables. Which we do in this specific instance because we want to say, hey, only do like certain, or only like center it at this point, or do stuff like that. So that's going to need our width variables. It's going to need our height kind of stuff. So we can do that way. And then there is a pre-programmed kind of black, etc., sort of, if you do color codes, but it's just so much easier to just say, hey, here's the color code that I want for black, or if you know your background's going to be green at all times, setting up your colors that you know for sure you want. And again, this is called a tuple, and a tuple just is basically a list that cannot be changed. Inside of Pygame, these work off of 255 or 256s, so your numbers are going to be between 0 and 255 for each of your values. So black is 000, true red is 25500, true green is 02550, and true blue is 00255. But yeah, you can find all sorts of, if you want, like, let's see, RGB magenta, you'll be able to find, you're not looking for hex, you're just looking for the RGB, so like this, so like 250, 94, 167. So you'll be able to find those relatively easily just by searching. And because it's Pygame can run just about any color that you can see. So that's pretty cool. So once we've got all these variables, we actually have to do something with them to make that screen the size that we want it to be. So we have to create a variable for our surface. And sometimes people call it surface, sometimes people call it screen, sometimes people call it area. It just kind of depends on what they've been taught or how they've been introduced to it. I personally like screen. I've also used surface a lot, but screen is the one that I tend to stick with. So screen equals Pygame display set _mode size. And what this is saying is, hey, I want you to create a working area. So I want you to create the display, and I want you to set it to the size, and I'm going to call it screen. So now anytime we're referring to like the thing that we want to print on, or the thing that we need to actually like put images to, we're going to do it to this thing called screen. Go away. And then to set our caption, we can just say, hey, Pygame.display, again, because this is calling, hey, what the display looks like. And then we say set caption, and then you're going to say whatever you're going to call it. I'm going to call mine chicken click. Now you're going to notice that where we did see camel casing or Pascal casing inside of Lua and Love, we really don't see it here. Everything is lowercase, and we've got the underbar, which we kind of talked about. We talked about the idea that in Python the underbar is king, whereas in Lua, camel and Pascal casing was pretty much the bee's knees. So once we have this, technically our screen is all set up, but if we run, and I haven't done anything wrong, it's not actually going to show anything. And the reason why it's not going to show anything is because we haven't actually told it to draw anything or to set up anything. So, like I said, it may or may not show anything. There's a good chance that it won't show anything. Yeah, so see we have our... And again, I talked about this a little bit earlier. For whatever reason, Repl and Pygame are having this fun thing where they're not really showing or doing anything with each other for like a couple clicks, so you have to like press the play button a few times. So yeah, it's not really doing anything, it's not really showing anything. We can click stop, and that's kind of the next thing that we have to do. We have to tell it, hey, now we want you to actually draw something. So to do that, we have to create what we ostensibly call a game loop. And so really it's just a part of the same code. It's just generally at the end of everything. So and depending again on who you're watching as far as tutorials go, or who you're like listening to, or what you're reading, depends on how they actually set up a game loop. In my case, I like using game over, but other people's like using while one, some people like using while play, some people, it depends. So my yeah, mine is game over. So to do that, we're just gonna say, before we start our loop, we're gonna say, hey, game over equals false, just so that we can actually say it. Technically, you wouldn't need to say it because since this hasn't been initialized, it's false. But just so that we can be perfectly clear that game over is false when we get to the start of this loop. And that comes in handy when we're talking about like resetting or replaying, because sometimes you'll forget about that. So now we can say, hey, while game over equals false, or game over not game over, or however we want to do it. Remember that in Python, true and false are capitalized. Now we have to say, hey, you know, what's going to happen during our game loop? And the number one thing that you want to put, and you will put pretty much every single time, is you're going to put a couple lines that are saying if the exit button. So generally in this top right corner, or I guess it's still there, you get a little X, and you want to say, hey, what happens if I click that? And what happens if a quit event exists? So what happens if I say, you know, press the Q button to exit? Like, so how does it exit? And that's basically, we just want to say, use the event type of quit. So in this case, we just say for event in pygame.event.get. And what this is saying is, for each event inside of this function, and there are a bunch of them, look at it and see if things have happened. And we want to say, hey, if the one that's happened, so if event.type is equal to pygame.quit, so if something has registered as quit the thing, then what do we want to do? And we just want to say here, because we've set up this game over, we want to say, hey, game over equals true. And that's kind of the base loop that you need. Or, I mean, you don't, and again, you don't technically need it, but it's the best one to start with, because it is really important to have that thing so that your game doesn't just hang forever and ever and ever. And then the next thing that you have to do is inside of your loop, at the end of your loop, and so everything else will go between kind of this and this line right here, is you have to flip your display. And we talked about this a little bit last week, insofar as the way that this works is that, think of it like a storyboard or one of those flip books that you had as a kid, where you would literally like, you'd draw something on the corner of a textbook and then you'd like flip it with your thumb and it would animate. That's kind of how Pygame and generally any kind of game engine works. They work on these kind of pages, and between frames you're just flipping to the next page. So what we have to do is we have to say at the end of our game loop, yeah, it's time to flip, it's time to change. If we don't say that, things get a little weird and can get bad. So just, yeah. So then, after all of this is said, we have to actually say, you know, what happens if game over is true. So once we fall out of the loop, all we've got to do is say pygame.display.quit. And this is going to actually call the quit function and say, you know, actually quit. So if this is behaving, and like I said, it's been having some issues, it may or may not run. Don't tell me we're going to have to do this again. So I ran into this issue last night, and it's why having multiple browsers installed is actually helpful, especially with Repl, because for whatever reason, so Pygame, actually, I know I told you guys about this idea that, you know, Pygame has been threatening to give us 2.0 for like 10 years, for almost a decade, and I was like, haha, it's so funny. Well, Pygame just celebrated its 20th anniversary, and as its kind of big 20th anniversary celebration, they actually released Pygame 2.0. So Pygame 2.0 has been playing interestingly with everything else. So, yeah, let's see. Let's see, will you actually run over here? So again, sometimes, you know, do I think Edge is the best thing in the world to have? No. Does it work in this case? Yes, when it actually runs. There we go. So you see, we now have our kind of our chicken click window. Things are happening. Well, nothing's happening because we haven't told it to do anything. But we actually have our window, like, running and alive and working. So, you know, that's at least a thing. So I'll remember that again. And if you've got Firefox, I don't remember if I have. I may have taken Firefox off of here. Oh, I didn't. Okay, cool. But Firefox probably works as well. I tend to Edge, and because I've got some other jobs that only use Edge. So yeah, it's a thing. So now that we've got that working, remember over here we've got our window, everything's great. Now we actually gotta, you know, make things happen. So the first thing that we're gonna do is we're gonna set up our chickens. And this is gonna look similar to how we did it for Love and Lua, with some slight variations, simplifying the code, things like that. So, yeah, and again, let me know if I'm going too fast or if I'm not going fast enough, etc., etc. So, we're going to use a term that you have probably heard, but you maybe not know what it is. We're going to use a term called iterator. And you've probably heard, we're going to iterate through a loop. We're going to iterate through a for. We're going to iterate. And all iterate means is it to go through, like step through. So step by step by step by step by step. And in this case, we're just going to create a variable called iterator, and we're going to use it all over the place. You could also call it y, you could call it I, you could call it whatever you want. I just especially when I'm teaching y'all, one of my big things is to make sure that variables are named something that makes sense. So in this case, that's what it's going to do, is it's going to step through until we get to the end of a loop and then set itself back. And we're just going to keep using this variable a bunch of different places. So to make this easier to dynamically change, or to change if we wanted to, you know, instead of having just 5 chickens, we could have 20 chickens on the screen at a time. I'm going to actually create a variable called num of chickens. And I'm going to set it to 5, like I said, because I think, you know, 5 is a pretty decent number to start with. So we're going to start with 5 chickens, but you could always come back and switch this over to 10 or 12 or whatever number you wanted, or 1. And because of the way that we're going to write this, it's going to make it so that you can, that just changing that number will change the whole program for you. So it makes life nice. Because yeah, I wrote it the really, really dumbed down way when we were doing Lua, because I was hoping that that was going to help you guys. I don't know if it did or not. So this way we're going to write it a little bit smarter inside of Pygame. So then we're going to create 3 empty lists. These are basically our arrays. This is what's going to hold our values. So we're going to call it start x, or you could just call it x value or whatever, because the reality is that it isn't your start x, because eventually it moves, so that may not be the best variable name, but it is what it is. And then we're going to call start y, who would have known, and then we're going to call speed. Because what we're doing for this one is we're going to create a random speed. So we're going to have our random start x position, we're going to have our random y position, and then we're going to have a random speed. And so like last time I had you guys, you would fill these out and it would be like 0, 0, 0, 0, 0, 0. You'd have like 5 variables in here. So because we have this, what we're going to do is we're going to actually create a loop, and we're going to use our iterator, and we're going to go through a loop, and we're just going to allocate or assign new stuff to everything. So we're going to go ahead and say, we're going to say, hey, while iterator, so while this thing that is currently 0 is less than our num of chickens, so while it's less than 5, so that'll give us 5 loops through. What do we want to do? Well, we want to actually append or add things in. But the first thing before we start doing that is that we know at the end of each of these, like at the end of each loop, we need to increase the iterator. Otherwise, it'll never fall out of that loop and it'll freeze the program will die. So as a result, the best option is to always say, hey, iterator plus equals 1. And so this says add 1 to iterator. And that's going to be at the end of our loop, and we can kind of space it down. And that way we know we have it there, because otherwise you'll forget. I forget half the time when it comes to things like this as far as iterators go. And some of you may be asking, well, why aren't we using a for loop? Well, technically, for loops don't work the same in Python Pygame. They work like for each loops rather than like pure for loops. So we don't really have the functionality of, you know, for int I equals 0, if it's less than 20 increased by 2 or whatever. We don't have, you can force it to do that or trick it to do that, but while loops are easier to understand, like, let's be real. Yeah. So what we're going to do is we're going to actually add into these. So we can't just go saying, hey, you know, start x, we can't say start x 1 equals. It'll error out because it says, hey, you told me this is empty. I don't actually have any indexes, so you can't do that. Instead, what we have to do is we have to append. There's a few different ways to do it, but definitely append is the easiest one, and that just says, hey, smack something on the end of it. So we can say start x dot append, and then we have to tell it what we want. And in this case, we want a random start x. So we want to do random. So random dot rand int. We could, so there's a few different weird functionalities as far as random goes. Just note that rand int is basically your best friend. And yeah, it only gives you an integer, but you can kind of trick it into be a decimal point. But for this game, it doesn't really matter. Let's just leave it as a random int. But you'll see, I'll show you how to use a different version that'll give us a decimal point as well in a little bit. So after that, we have to say, hey, so we want our random x to be between the left side of the screen, so we know that's 0, and the width, which we defined up here, But we want to make sure that the width is, that the chicken can fit on there. So we need to do minus the width of the chicken. And what's cool is, just like in love, we have a function to do that. We can say, hey, chicken dot get underscore width. And then, why are you angry? Undefined. Oh, because I haven't. Okay. Yeah. Like I said, I'm sick. I don't feel good. I did not add the chicken in. So let's add the chicken in. So up here, we're going to say chicken. And this is going to look remarkably like love. So equals Pygame dot image dot load. Oh crap. Do I have a chicken on here? Downloads. Animal file. PNG. Okay, I do. So the same way that we did everything else, you're just going to drag it over here. Chicken.png. So, yeah, it looks remarkably the same way that love did. Pygame.image.load. So now, see, it's not angry anymore. So now we're back down here. So we're saying, hey, we want a random integer. We want it between 0 and the width minus the chicken width. Now, there's one more thing that if you've looked at the documentation, I've also put. And that's where we have +1. The reason why there's a +1 at the end of here is because Python is inclusive for the first number, but exclusive for the end number. So say you were looking at a random int between 0 and 5 as your so you said random int 0, 5. The only numbers that could possibly show up would be 0, 1, 2, 3, and 4. 5 would never show up. So to make sure that we can get that last little number in, we just add a 1 at the end. So now that we've got that, we can say, hey, start y, let's do something to you, and let's append start y with another random, and we're going to say 0 because we know that we want all of these numbers to be lower than 0. And we're going to say 0 minus random dot rand int. And in this case, we're going to take the chicken dot get height. And this is just so that we can make sure, again, to get it to start off the screen. And then randomly or arbitrarily, however far away you want the next chicken to be. So in this case, I'm going to say chicken dot get height times 2. It's really up to you what you want for that. So we've got our random start, our random starts for X and Y. And now the last one, which is something that we didn't really do in the last one, is we're going to give it a random speed. So in this case, as you've seen probably with the other demos that I've shown, or if you looked at the other code, when I do speed, it tends to not be something that's like over 1. So we need a decimal point. So the question is, how do you really do that decimal point? Well, we could get a random int and divide it by 100 or by 10 or however you want. However, you can also get a random decimal number between 0 and 1 if you just call random. So what we're going to do here is we're going to do a random.random, and then we're going to add it to a random.randint, just so that we can have something between 0 and like 3 as your speed, just to give it more range. So again, we can say speed.append, and then random.random, which doesn't need any parameters. And then the problem though is that because we're doing a randint, that's an integer. Like, it reads as an integer, it knows it's an integer, so it can't actually add random, which is a decimal point, to an int, because it's like, yo, those two they just don't. I know they're numbers, but they don't mesh. They both have to be floats for me to be able to add them. So we have to cast, and to cast it's really easy. You just say, hey, float, and then you write your rand inside of here. So random.randint, and we're gonna say 0 and 3, and then outside of that we're gonna go ahead and we're gonna add 0.1. The reason why I do this last thing here is because under our current written thing, however inconceivably tiny it is, we could end up with 0.0 being our value, which would mean our chicken wouldn't go anywhere. So we need to make sure that there is some sort of like base movement. So in this case, I just add a 0.1 to make sure that it actually moves on the really, really minuscule random chance that it ends up at a 0.0. So with that, we now create these 3 lists with 5 objects in them each, which means we now have 5 values for chickens. Easy. Like, instead of having to write it out each time, we now did it in one loop, one easy kind of digestible thing to push it into there 5 times. And again, if you were to change this number to 6, 7, 8, it would do the same thing. It would just keep making it bigger and bigger and bigger, because that's kind of what we've done. We've made this much more change friendly. We'll go with it that way. So now that we have all of that, we need to start animating and drawing things. Because if we were to run right now, again, for those of us just joining, for whatever reason, you're going to find that Pygame and Repl are playing dirty games right now. So occasionally, especially, and I don't know why, Chrome tends to be the problem more than anything else, but if you come over into, again, I have Edge up, not because it's the one I like using, but it's because of the one I have and that's easy for me to get to. If you run it in a different browser, it tends to run okay. And again, I joked about the fact that we were never going to get 2.0. Well, for their 20th anniversary, they gave us 2.0. And again, you're going to get this thing where it exits, and you might have to do it 2 or 3 times before it actually plays. So don't freak out about it. It's not your fault. It's just something happening right now. So, okay. So, yeah, we're still good. There are no errors. Everything is great. We just have our window. That's all we need right now. So, this one. So now we kind of have to make things move, or we have to make things update and move, etc., etc. So you kind of have your choice as to whether you want to draw things first or whether you want to set them up to animate. If you read the document, I'll tell you that, like, in my brain, I always think about drawing before animating. So we're going to go ahead and do that. So inside your game loop, which again is just same part of the code, it's not anything different. Right before this pygame.display.flip, because you want to be in this kind of while loop, we are going to add, I'm going to add a comment here that says draw stuff. Just so that we know that that's what we're doing right here. So the first thing that we have to do is we have to say, hey, between screens, so between flips, we need to fill the screen with black so that we can't see the previous screen. Because if we don't fill it with black, think of it like transparencies. Or again, if you guys are animation people, it's like onion skinning. So if you don't fill something with black, then you're going to see the stuff from the previous actions. So you'll get ghosting and all sorts of weird, crazy things that happen. So the first thing we have to do is we have to say, hey, screen.fill. And what do we want to fill it with? You can put a number here. So say if you knew that the number was going to be like 200, 0, 0, so that would be kind of red. You could do it that way. But because we've defined black, we can just say black. And we define black up here. Black. And then we're going to use our trusty iterator again. We're going to just say, hey, iterator, if you weren't already set to 0, we're going to say, hey, set yourself to 0. And then again, we're going to say, while iterator is less than num of chickens, you're going to use this line a lot. And remember, my tip is to always start this with iterator plus equals 1, so that we know at the end of this loop that you actually hit that, because otherwise it will hang and the loop will never end. So then we have to say we want to do screen. So we want to say, hey, what do we want to draw to? We want to draw to the screen, which is a variable that we created up here. Depending on the tutorials you follow, they may call it something different. They may call it display, they may call it screen, they may call it surface, they may call it, there's a bunch of different words. Screen is the one that I like to use, but it's up to you. So we're going to say, hey, draw to the screen. So we want to screen, and we want to blit. So the term here, blit, is, it literally means to draw. It literally means, hey, shove this on the screen. Show this here. And it's just, it's a term. It's a term. It's an old school term. And we're going to say screen.blit, which is equivalent to Lua's, or Love's, love.draw. So, and then we're going to say, what do we want to draw? Or what do we want to blit? We want to blit a chicken for each of these kind of iterators. So for the 5 times that we're going to do this, because we set num of chickens to 5 and this is 0, so we're going to hit it 5 times. We then, where do we want to draw it? And this takes a tuple, so it takes an x and a y value. So in this case, the x value is going to be start x. And remember, we've already initialized, so we've already put 5 values into start x. So we can call it by the iterator. So the first one will be start x 0, the second one will be start x 1, the third start x, so on and so forth. So we can call it, because we're going to be increasing that iterator, we can just get those values. And then the second is going to be start y, and again, iterator. Cool. And then, to make sure everything is like triply, quadruply checked and everything, after we are out of this loop, and this isn't really necessary, but it's a good idea, sort of, we're going to reset iterator to 0. Just to make doubly, triply, quadruply sure that iterator is set to 0. And this may be because later on we're going to draw something else or something like that. It's not 100% needed, but it's not the worst idea either. And if you're following my example code, I have it in there, so we'll just leave it in there for now. So yeah, so technically this should run. I can at least see if there are any errors. I should be able to see if there are any errors. No, you're not even going to top that up. Okay. like I see, it's gonna have to update every time. It's annoying. They'll eventually have it actually installed correctly so that it doesn't have to do that. But will that happen before you guys are here? I don't know. Or before you guys are done with Pygame? I don't know. Okay, so yeah, we do have an error. Invalid destination for Blit. Oh, that's because that doesn't need to be there. That needs to be there. Okay, so just with that one little change, again, we can come over here, and if we... I should just code over here. That's what I really should do. So that we don't have to do this every time. Am I not logged in over here either? Stop. Okay, yeah, so now see, we're not getting any errors. We're good now. Life is happy. Yeah. Okay, so now that we have, you know, it's technically drawing, but we can't see anything because nothing's moving onto the screen. Now we need to animate. So above our drawing, and this is a preference thing more than a, like you have to have it in this order thing. You should have it in this order, but do you always have to? No. I'm gonna say update stuff. And inside of here is where we're gonna do our animation. So for our animation is really simple. We've talked about how animation works previously. You've seen how animation works because of your assignments, stuff like that. And again, we're gonna use our iterator. We're gonna set it to 0. We're gonna again use while iterator is less than num of chickens. And then we're just going to look at each of the values inside of start y. And then we're going to add to them whatever the matching value at that iterator is for speed. So, and when I say that, what I mean is, so for like start y1, we're going to look at speed 1 and see what value speed 1 has, and we're going to just increase start y1 with speed 1, and therefore creating, yeah, movement. And then again, because I almost forgot to do it, and I told you guys that's why I always try to do it first, iterator plus equals 1. So now that that's there, that's it. That's literally getting things to move. So if we come back over here and refresh this, and run. Run. Oh, did I break everything now? I broke everything now, didn't I? I broke it! Yay! broken. Yeah, if it gets to there and it hangs there, there's a good chance that it's not going to actually load all the way. Why it's doing that, I don't know. It wasn't doing it a week ago. I'm pretty sure it has something to do with either it has something to do with the dark background, or it has something to do with Pygame 2.0, which I guess would also be another issue. So let's just open another browser. Yes? No? Maybe so? Okay, cool. Firefox. Great job. Okay, so let's figure this out. Settings. Light. Stop. Run. Out. Go away, no. That's fun. I don't know why. Maybe that's why I don't ever use Firefox. Let's try this again. Okay. So, if this too is happening with you, Pygame should have decent documentation on installing Python. So, you use Python 3.7.7, so you have to install Python first. And then the best way to install it is with the pip tool. Yay! And it'll tell you how to do that. However, you can find all sorts of other ways to do it. Whether those are easy ways to do it or not is a different ballgame altogether. So, just if this is a problem, let me know. Come on, guys. I'm just trying to teach a class while I don't feel good. Okay, let's try. that's a window. Okay. Settings. Just do your thing. Also, yeah, I'm very sorry that this is causing problems because Repl.it. Alternatively, it could just be my internet based on the fact that this isn't loading like it's supposed to. Ah, that should be fun. And again, I really do suggest running your code every few steps so that you know that you've got things right, because it's easier to find when you've made mistakes. One of the things that Love definitely has on Pygame is the fact that Pygame doesn't display your errors up here. You've got to find them down here. So there we go. So we've got chickens moving. There we go. Yay! I don't know why all this worked, but it does. So we've got chickens moving. That's all that really matters, right? We've got chickens moving. You can see you've got this one guy moving very slow. The other guys move pretty fast. The one thing that I didn't really talk about was the fact that, and now I'm going to be stuck with this. Let's see. The one thing that you're gonna find is that you oh wait, no, that's what I was gonna say. So as far as Python goes, Python's random, which I didn't talk about earlier, because y'all saw I didn't do a random seed. You can do a random seed if you want to do a random seed, but you don't need to do a random seed. That's not what I want. You don't need to do a random seed because Python has a pseudo random that's a lot better than Love's. So yeah, if you were doing like encryption or something like that, you would of course want to do like your own random seed. But as far as we're concerned, this works. So, okay, so, you know, we've got chickens moving, everything's going hunky-dory. We saw our chickens running. Now that it's not going to run again. Okay, no, so we've got chickens running. They're moving. Things are happening. They're in random positions. Life is good. They're going at random speeds. We've got one that either went super okay, one that's gone really slow. So they're in random positions, they're in random speeds. Life is fine. So now we've got to worry about, you know, the whole idea of clicking the chickens. And clicking the chickens works pretty much exactly like what you guys have done in the past. Or at least what I showed you guys how to do in the past. So there is the option to use git rex, but the issue with that is that you actually have to move. You have to, if you want to use, like if you looked at the bounce tutorial that I had, or the bounce demo that I had, and it talked about using rex, it used a function called move. So the rect creates a box around an image, and if you want that rect to move with the image, you actually have to use the move function. You can't just move the image, because the box will stay in the initial position. So, as a result, you know, if you want to move with the rect, and you want to use like left and right on the rect, you gotta move the rect. So I don't do that only because, again, that's not always a functionality you have with every engine. And since we were in Lua, I didn't really think about it that way. So basically what we're going to do is we're going to do it the same way that we would have done in Lua, where we check, you know, the start X and then start X plus the width and then start Y plus the height. That kind of stuff. So we need to write our mouse stuff. So in this case, we're going to say, hey, we're going to be inside our game loop still, because pretty much everything is just going to be inside your game loop. We're going to say click. And just like with Lua and Love, we've got built-in stuff for that. So the first thing we're going to do is we're going to say, hey, if pygame.mouse .get pressed, and then we have to tell it which mouse button. In our case, it's 0, because 0 is the left click, I think 1 is the right click, and 2 is the center mouse click. Yeah. And then we're going to say, yeah, so now we have our if loop. And we also, however, we don't want to just, know that a click has happened. We want to know where the click has happened. So we have to say, we have to store, let's store the coordinates in a variable called coords. And we're going to equal it to pygame.mouse.get position. So cool. So yeah, if we spell mouse right, that's cool. So now we can say the same thing we've been saying every other time. Iterator equals 0. While iterator is less than num of chickens. And then we can make sure that we're going to say iterator plus equals 1. And now we can do our very long if statement to find out whether things are being clicked correctly. So what we can do is we can say if, and because coords is going to be the way that coordinates print out, so the way that this prints out pygame.mouse.getPosition is it prints out as x comma y. So it prints out as a tuple. So to access it, we access it the same way that we access everything else, and we can say, hey, if coords 0, which is the x value, is greater than or equal to start x iterator, and coords 0 is less than or equal to start x iterator plus chicken dot, what do we have capitalized as chicken? Oh, right there. Okay. Chicken dot get underscore width, and because we've checked the x, we need to check the y values as well. We want to say and coords 1 is equal to or greater than or equal to our start y iterator, and coords 1 is less than or equal to start y iterator plus chicken dot get height. Then we want something to happen, because this means, you know, we've actually gotten in the box of a chicken. So what do we want to happen? We want, because we know what we want to do, is we want to reset everything. We basically just want to reset that chicken back to the top. So there's a few different ways you could do that. To be honest, your best option would be to make kind of like a reset function. However, I'm just going to grab these right here and we're going to use them. And what we're going to do is we're going to come here. We're going to paste these. We're going to make sure that these are where they're supposed to be. And then we are going to stay start x iterator equals, and then the same here, start y iterator equals, and then speed iterator equals. And after that, because we've clicked a chicken, we're going to break our loop. So all this does is say, hey, if you've clicked inside of a chicken, take the chicken that you clicked and reset all these values, or set all these values back to what kind of they were originally done. Again, it'll post at a new random spot at a new random speed. And it should like actually work. So if it actually works, oh, well, that's not going to actually work because this is the old version. So let's refresh. Let's run. If you're having to do this two browser thing, always make sure that things look like they've changed here, because there's occasionally a point where they won't. And we're going to see, again, remember, you're looking for, this will be okay, as long as it's saying, like, these last things are serial number, failed request, current serial number, and output stream, you're pretty much okay. You're looking for something that's going to have, like, an actual error down here to cause problems. Don't do this to me. Or, I guess, do this to me. Cool. So, let's try running over here. All right. Again, it's usually not this much of a problem. That's not what I need. It is usually relatively easy to get this to work. Usually, Pygame works like 100 times better than Love does. But I'm pretty sure that the new update to Pygame broke Repl. So, again, you may want to go ahead and install it on your system and then throw all the code on Repl later down the line. I mean, on the plus side, Pygame has made it so that with 2.0, it's a lot easier to actually build an executable. Okay, so yeah, so we should be seeing when we click our chickens, when we click our chickens, you're seeing chickens go back up to the top, or at least disappear. So, okay, so we have chickens working. I promise they're actually working, and it's just not me clicking 800 times. So our chickens work. Yay, chickens! So, now we need to make kind of our game over what happens if the chickens hit the bottom. So if we come back over here, and the next thing we're gonna say is we have to actually do something that's like, you know, what happens if they hit the bottom. So inside of our update, we can actually check while we're doing this kind of thing. Hey, you know, instead of just increasing the speed, before we increase the speed, let's check and make sure that they're not over the edge. So we can say if start Y iterator plus our chicken height, so chicken.get height is greater than height, which was that value that we created earlier. And to be entirely honest, to be the simplest that humanly possible, we could say, hey, game over equals true. And remember, that's got to be capitalized. And then break. So this will 100% close the game out once a chicken hits the bottom. So if we come back over here, and we run, and we run, and we run, and we run. I guess while I have you guys here, as a side note, you can view the schedule for next semester. It exists. So if you're already trying to think about what classes you're wanting to sign up for next semester, they exist. Okay, so chickens, and when they hit the bottom, we close out of the game. Easy peasy done, and you know, all that jazz. However, it doesn't really look good, doesn't really feel good to just have things close out like that. So what I wanted to walk through kind of for this last little thing was to show you how to make kind of like a replay screen. Because that's going to make your life easier, right? Or at least, maybe not easier, but it'll make things look nicer. So up here, in kind of where you've loaded everything, and again, you don't have to keep this up here, but it's nice to keep things, you know, all your load stuff together and all your game stuff together, etc., etc. We're going to create a new variable, and we're going to call it, and it's going to be outside of this loop. Completely outside of this loop. Ignore the fact that I have it inside of the loop for the iterator, or for the in the example document, it's actually inside of this loop. It'll work there, but it doesn't need to be there. So replay screen equals false. Now what we're basically going to do is we're going to create loops for everything so that things only draw when replay loop or replay screen is false. So what we're going to do is we're going to say, hey, we're just going to come through here, and I'm going to say, you know, I know that I may want to use this coordinates and this press system for the replay screen because I need to be able to, you know, click on buttons in quotation marks. But I know all of this stuff only needs to happen if it's not a replay thing. So we can say, hey, if replay screen equals false. Did I do that up there? Okay, cool. And then we just take all of this all of this and we tab it over. So now we know that if the replay screen is false, this is going to play, but if it's true, it's not going to do anything. In the same way, we come down into update, and all of this stuff can go in. So we just say, hey, if replay screen equals false, and tab over. And the same down here. We know that this stuff right here is going to be in there. So what we can do is we can say if replay screen equals false, now for us to be able to see this, we're just going to add an else statement here. We're going to say else, and we're just going to create a new fill for the screen so that you can see that there is a different color. So with all of that done, we should be able to come over here and run it. Let it do its thing. But yeah, like I was saying, the schedule is up so you can see when classes are being offered. Pretty much they're being offered, a lot of them are being offered the same time that they were this semester. So we should see when things hit the bottom. Oh, we actually get an error. Maybe? Oh no, we don't get an error. We never told it to actually change over to game over to here. We don't want it to be game over equals true because that just exits out the game. What we want it to be is replay screen equals true. So now if we run it and let it do its thing, there are some classes that are only offered in the spring that are being offered as a side note, or that are currently only being offered in the spring. So I don't think any of you are programmers that still need to take the course, but game dev in C++ is being offered in the spring. So digital sound is being offered, which I know was one that everybody was kind of panicky about. Some courses are doing hybrid, some courses are doing all online. Most courses are going to do all online, and if they are doing hybrid, it's like only 5 kids can be in the classroom at a time anyways, so yeah. Can we not do this? Like, all I ask is for you to work. My cold medicine is starting to wear off, and I would like to go back to sleep. Okay. So see, now when we hit that bottom of the screen, we turn to red. Which is a little bit better than just, completely closing out of the program and you thinking it crashed. Maybe a red screen isn't the best option either, but, it works. So, how do we make this a little bit more functional? Well, we add text to it. You know, we tell it to do things. So text is a little bit weird inside of Pygame. Lua and Love is definitely a little bit friendlier, but it's okay here. So the first thing that you have to realize is that fonts cannot be variable. So once you set a font size, that's it. You can't change it, at least not easily. So we have to set our fonts up first. In this case, and setting up fonts and things like that, it's going to be a lot of trial and error for you to figure out like exactly what you want and how you want it. There's no real true science to getting this to how it needs to be, but yeah. So I'm going to call it big font because literally I'm going to have a big font and a slightly less big font. But to set up a font, you're going to do pygame dot font dot sysfont, and you're going to notice for the first time we have capitalizations and things like that, and that's because this is calling not really from the Pygame but calling from the C library that it's built on. And in this case we're going to say none, and that's are you supplying a font, and then 200. So this is just taking whatever your system font default is and using that. And then we're going to say play again, text, and we're going to set it to be to use the big font and to render using that big font. What do we want it to render? Play again, true, and then you've got to give it a value as to kind of what color it needs to be. So in this case I'm going to make it this weird kind of lime green color, so we're going to do 0, 200, 0. Because why not? And then what I'm going to do is I'm going to set up where I want it, because I want it to be smack center in the screen. So to do that I'm going to call it packs, so play again X. And to find the center, we're going to take the center of the actual screen, so width, and we're going to divide that by 2. And then, because text actually comes in with recs, just like images do, you can actually get the width of your text, and you can slice that in half to figure out where it's going to be, because you want to put those centers right on top of each other. So all you have to do is subtract the play again text dot get rect dot width, and then divide that by 2, and that'll get you like smack in the center. And then for yes and no, let's add a question mark here. For yes and no, you can do small font equals pygame dot font dot sysfont, none, and 100. Like I said, slightly smaller font, or slightly big font, not as big. And then we're going to set up the yes text, and that's going to be small font, as I can type, dot render, yes, true, and then we're going to set it with the same color. 0, 200, 0. And technically this is just going to read as what they consider true green, because I haven't put any values in the other ones to equal that kind of, yeah. So it turns out really freaking bright. At least on my screens it does. So and then where are we going to put it? Well, I'm going to put it at the quarter point, basically. So to do that, I'm going to say that's going to equal the width divided by 4 minus yes text dot get rect dot width and divide that by 2. And now I'm going to go ahead and copy these 2 lines because our no text is going to be pretty much the same. So no text, no, and then this is where this one's going to be width. It's going to be a little bit different. It's going to be width minus width divided by 4, so because you want to get that other side quarter, and then minus that. So technically this is set up. None of this is drawn yet though. Like, this is just the setup. So now we can go down into where our draw is, where we have this screen fill, and we can blit things. So we're going to say screen dot blit play again text, and where do we want it? We want it at packs, and then I hard coded this in because I didn't feel like figuring out how I wanted to do that. So screen dot blit and then yes text, and then yes x comma 450, and then we can say no text, no x 450. So now if we come back over here and wait 8 years, that helps, right? If we come back over here and we tell it to run, and it thinks really hard. Again, I don't know why it's this slow now, of all times. Nor do I know why you basically have to start it 3 times before it'll actually run. Okay, so we got our chickens going. Things are happy. One of you hit the bottom. So we get our text. Play again. Yes, no. So things are hunky-dory. Now we have to make these clickable. And you already know how to do that. Really, you do. It's literally the same exact code that we've been doing for like how to check if we've clicked on something else. So to do that, we come back over here and basically we're going to come into where we have our mouse press right here, and we're going to take this if statement and we're going to create an else. So we're going to say, hey, you know, because this says if replay screen is false, but we want to know what happens if replay screen is true, then we can check yes, and then we can check no. And basically what we do here is we're kind of do the same thing that we did here, where if the coordinates equal that yes button, reset everything and set replay screen to true or to false. Wow. So we're going to say, hey, if chords 0 is less than yes x, or is greater than yes x, and chords 0 is less than yes x plus yes text dot get rect dot width, and chords 1 is greater than 450 because we hard coded that in, and well, chords 1 is less than 450 plus yes text dot get rect dot height. And because we literally just want this stuff, I am just literally gonna copy this. I'm literally gonna copy all of this because we still need that iterator. We can actually copy all of that. Because basically we don't need this part. What we do need is this. So we do need, while the iterator is less than the number of chickens, do all of this. We don't need to break. We need our iterator to be inside of our loop. But so yeah, we can actually, there's one more thing that we have to do because we haven't set it. We need to say, hey, iterator equals 0. Just to make sure that our iterator hasn't somehow managed to be a different number somewhere along the line. So, and then after all of this is said and done, once we're outside of resetting all of our chickens, we need to say, hey, that replay screen that we had as being true, it needs to go back to false so we can play again. So now we need to check no. And for that, we're going to do the same thing. We're going to say, hey, if chords 0 is greater than no x and chords 0 is less than no x plus no text dot get rect dot width, and chords 1 is greater than 450 and chords 1 is less than 450 plus no text dot get rect dot height, then what do we want to do? Well, that's easy. Game over equals true. So, if I haven't managed to mess up tabbing, then, or done another error somewhere, which is always a good possibility. We will see in a minute. Okay, so when we click yes, see, we've got our chickens, we can play again. And we can continuously keep playing because it'll keep resetting and keep redoing what it wants. And you're seeing chickens falling in slightly different positions. And then if we click no, it closes out of the game. Technically this should go away, but you can see that the game is closed out of because that bar goes away. So okay, and that was really the end of what I wanted to show you. You can use the same sort of idea to do a title screen. You could also do if level equals 1, or if level equals, and have multiple level numbers. And so if level equals 1, then that's your title screen. If level equals 2, then that's your game. If level equals 3, then that's your credits or whatever. There's a lot of different ways to do that. It just kind of depends on what you want to do. So, yeah. Are there any questions? Wants, desires, needs, hopes, dreams that I can help with? Okay, well, this code is there for you. It's up for you. The nice commented version is up for you. You have the written version as well. If you come over here, you've got this PDF file. You have that PDF file, which literally walks you through step by step. Yeah, it walks you through step by step. You've also got the link to the Repl. I'll put the video that we just walked through, painfully walked through, so that you can watch it as well. Again, if you're going to use this as the basis for your game, it better not just be this. You better, ramp it up, make it better. At the end, I have a couple of things where I was like, you could do this, this, and this. You could avoid falling things. You could even use something to catch them. Maybe only click on certain things and avoid others. Maybe there are power-ups that speed or slow down. Make this more of a game. You guys technically still have 2 weeks to do this, so yeah. Next week is again a lab week. I'll probably have another demo or something that I can show you guys depending on what you want. Yeah. But so I guess do it to it. Use your time wisely. Message me if you have questions. I may or may not be available today because, like I said, I am sick. I am beyond sick. So I've basically been sleeping nonstop for the last couple days. It's not fun, but it's at least not corona. So that's, small favors. Okay. So with that said, I will leave you to it, and I will set up the recording. I will upload the recording, and I will talk to you guys next week.